So hello guys, welcome to our channel NIPER Solutions. So today we are going to discuss about the very important topic from your organic chemistry, that is the aromaticity, that is the Huckel's rule. ओके सो ये टॉपिक बहुत ही आसान है, बहुत ही कंसेप्चुअल है. ठीक है, इसके बाद आपको कोई भी कन्फ्यूजन नहीं रहेगा कि कौन सा कंपाउंड एरोमेटिक है, कौन सा एंटी एरोमेटिक है, कौन सा नॉन एरोमेटिक है. राइट. सो जितने भी आपके डाउट्स होंगे सब क्लियर हो जाएंगे. ठीक है, बस आपको ये पूरा लेक्चर, पूरा टॉपिक ध्यान से देखना है. ठीक है, राइट. तो चलो शुरू करते हैं. स्टार्ट फ्रॉम द फर्स्ट वन, that is the rules of aromaticity. There are the four different rules of aromaticity. The first one is the cyclic, right? Your molecule must be cyclic. Second one, your molecule must be in a conjugated system, right? Means that are the delocalized electrons. Okay. Then third one, your molecule must be 4n plus 2 pi electrons. And the last one, your molecule must be planar. सो कोई भी कंपाउंड अगर चारों के चारों भी कंडीशन सेटिस्फाई करता है तभी वो एरोमेटिक होगा. अगर कोई भी एक भी कंडीशन सेटिस्फाई नहीं करता है तो वो नॉन एरोमेटिक होगा. ठीक है, तो अभी हम डिफरेंशिएट करेंगे कि कौन सा कंपाउंड एरोमेटिक है, कौन सा नॉन एरोमेटिक है, एंटी एरोमेटिक है. हम सब एग्जांपल्स भी उसके देखेंगे. बट बिफोर गोइंग टू द एग्जांपल्स हमें पता होना चाहिए कि साइक्लिक सिस्टम, व्हाट इट इज़ मीन बाय द साइक्लिक, व्हाट इट इज़ मीन बाय द कंजुगेटेड सिस्टम, राइट, व्हाट इट इज़ मीन बाय द 4n plus 2 इलेक्ट्रॉन्स. तो ये सब कंडीशंस हम एक एक करके देखेंगे कि ये होते क्या है कंडीशंस. राइट. सो फर्स्ट वन इज द साइक्लिक. ये तो बहुत आसान है, सबको पता है कि साइक्लिक इन नेचर मीन्स दैट इज वेरी सिंपल. सो कंपाउंड शुड बी साइक्लिक इन नेचर. इन द फर्स्ट एग्जाम्पल बेंजीन एंड 135 हेक्साट्राइन हियर. सो द बेंजीन इज इन द cyclic form and the second compound is not cyclic, so that's why it is a not aromatic. Similarly in the second example of pyrrole and in tropylium cation also, right. But very important one thing here, just to clear, not all cyclic molecules are aromatic. Means just only one condition is not important, right. It has to follow that all the conditions, not only the first one, right. Means molecule must be cyclic, that's okay, but it has to be follow that other conditions also. Means it should be a conjugated system, right. It should have the 4n plus 2 pi electrons and the molecular must be planar, or it is the sp2 hybridized atoms in your molecule. Okay. So here is the first one, that is the cyclic. Second one is about your conjugation system. So what is meant by the conjugated system? So conjugated system is nothing but your delocalized electrons, right. So what is meant by the delocalized electrons? So your delocalized electrons means your your sigma and your pi bond are alternative to each other. Sometimes it is replaced by like a lone pair of electrons, or any positive charge or any negative charge, right. So these are nothing but your conjugation system. In first example in pyrrole, the all ring atoms are conjugated, right. But in the second one, here is a positive charge on the carbon and nitrogen atom is not in conjugated system. Similarly here in second example, the first compound is the aromatic, but another one is not aromatic because the one carbon in the second structure, that is your sp3 hybridized. And similarly in third and fourth one, right. So his compound is not aromatic, this one and this one are not aromatic because in both carbons are the sp3 hybridized, right. So these are the rules, or these are the conditions, so it has to be satisfied for any aromatic compound. Okay. So next one, so 4n plus 2 pi electrons. So what is meant by 4n plus 2 pi electrons, right. So if your compound is having the pi electrons like 2, 6, 10 or 14, it means your compound is aromatic in nature, right. So that is the condition is 4n plus 2 pi electrons. Means pi electrons कितने होने चाहिए, 4n plus 2, and what is the number of n? N should be a 0, 1, 2, 3 likewise, right. and if you are getting the pi electrons like 2, 6, 10, 14, 18, 22 and so on, right? So that is the 4n plus 2 pi electron, and that is nothing but your Huckel's rule. Okay, here we are differentiating between aromatic, anti-aromatic and non-aromatic compounds. तो ये बहुत ही इंपॉर्टेंट है, बिकॉज एरोमेटिक एंड एंटी एरोमेटिक में कंडीशंस आर वेरी सिमिलर, राइट? सो फर्स्ट वन इज साइक्लिक, this one. Second one, your molecule must be a flat or planar, and third one, your molecule or all the atoms are sp2 or sp hybridized, right? So sp2 hybridized is very important. Just is difference in between this one. Here are the electrons. In aromatic there are 4n plus 2 pi electrons are there, but in anti-aromatic 4n pi electrons are there. So that is the differentiating point between your aromatic and anti-aromatic compounds, because first three conditions are very similar in your aromatic and anti-aromatic. Just difference is there. In aromatic compounds 4n plus 2 pi electrons, and in anti-aromatic 4n pi electrons are there, and you have to remember this one also. So what are the pi electrons in your aromatic compounds? These are 2, 6, 10, 14, 18, and in anti-aromatic 4, 8, 12, 16 and 20. आपको ये याद रखना है, क्योंकि आपको पता होना चाहिए कि कितने पाई इलेक्ट्रॉन्स आपके कंपाउंड में है, और अगर आपको ये पता है कि कितने पाई इलेक्ट्रॉन्स है, तभी आप डिसाइड कर पाओगे कि आपका कंपाउंड एरोमेटिक है या फिर एंटी एरोमेटिक है या फिर नॉन एरोमेटिक है, ठीक है? तो अभी आपको क्या याद रखना है इसमें से? दैट इज द numbers of your pi electrons, right? Okay, the next one. Okay, here are the example of benzene anion and the pyridine. So in benzene anion there are the 3 pi bonds, means 6 pi electrons. So here in anion the lone pair is there, okay? So that lone pair is not involved in your pi bonding, because the lone pair on carbon is at 90 degree to pi system, so there is no overlapping here, right? So lone pair on carbon is at 90 degree to pi system, there is no overlapping, so don't count as a pi electron. That is very very important. आपको वही लोन पेयर काउंट करने हैं जो कि आपके पाई बॉन्ड सिस्टम में इन्वॉल्व होंगे, जो कि डीलोकलाइजेशन के लिए रेडी होंगे, राइट? जो कि ओवरलैप नहीं करते हैं, आपको उसको काउंट नहीं करना है. सो सिमिलरली इन केस ऑफ pyridine, the lone pair on nitrogen is not part of the pi system. Okay, why? Because it is also at the 90 degree to your pi system. So that's why benzene anion and the pyridine both are aromatic molecules. Okay, please remember benzene anion and pyridine both are aromatic molecules. Next, cyclopentadiene anion, it is also having a 6 pi electrons, right? This one 6 pi electrons, because here are the 4 pi electrons from the 2 double bond and 1 lone pair, that is equal to your 2 pi electrons, means total 6 pi electrons are there, and we know the 6 pi electrons means your compound is aromatic. What is that series? 2, 6, 10, 14, 18, 22 and so on, right? So that series is your aromatic compounds. Similarly in pyrrole there are the 6 pi electrons, because here in pyrrole the lone pair of electrons are involved in your pi orbital or the pi system, right? So that's why pyrrole is also aromatic compound. Okay, the next furan. Furan in oxygen, here are the 2 lone pairs of electron, right? So one lone pair is involved in your pi system and another is not involved in your pi system, because here you can see the lone pair at 90 degrees to the pi systems don't count as a pi electron, means only one lone pair is involved in your aromatic compound, right? And another one is not involved in your pi system. That's why furan is also aromatic one. Similarly in imidazole, right? So similarly in imidazole also here are the 6 pi electrons, right? Because the pi electrons present at n and NH. So NH pi electrons here. So these are involved in your pi system but the lone pair present at here, like on nitrogen, these are not involved, and these are at 90 degree to the pi system. So that's why only one lone pair is counting at the time, at the counting of your pi electrons. So these are the 6 pi electrons, right? So these two compounds are also aromatic. Please remember this: cyclopentadiene, anion, pyrrole, furan, imidazole, these all four compounds are aromatic in nature. Okay, here you can understand the all Huckel's rule or the rules of aromaticity. Okay, in the first compound हम एक एक करके देखते हैं कि क्या सीन है अभी, ठीक है. In the first compound, cyclopropene, right? So the compound is cyclic, but it is not conjugated. Why it is not conjugated? Here this कार्बन इज sp3 हाइब्रिडाइज्ड. अगर एक कोई भी कंडीशन सेटिस्फाई नहीं करता है तो ये कंपाउंड डायरेक्टली क्या हो जाएगा? नॉन एरोमेटिक. क्या हो जाएगा? नॉन एरोमेटिक, ठीक है. इन नेक्स्ट वन, साइक्लोप्रोपिन कैटायन. सो ये भी कंपाउंड साइक्लिक है, कंजुगेटेड है, ऑल एटम्स आर द sp2 हाइब्रिडाइज्ड, मीन्स प्लेनर भी है. बट व्हाट इज द नंबर ऑफ योर पाई इलेक्ट्रॉन्स? दीज आर द 2 pi electrons. And we know what is the series of our aromatic compound. These are the 2, 6, 10, 14, 18, 22. Similarly, right? So your second compound, that is cyclopropene cation, that is your aromatic compound. And the third one, your cyclopropene anion, that is also cyclic, that is also conjugated. It is sp2 hybridized, means planar in nature. So what it is? But here the pi electrons are 4, and we know the 4 pi electrons, it means the compound is anti-aromatic, because in 4, 8, 12, 16, 20, 24, so this series is from your anti-aromatic compound. Because in anti-aromatic compound your pi electron system should be 4n, and in aromatic that is the 4n plus 2. Okay, next cyclopentadiene. Here is also in the first structure your one carbon is sp3 hybridized, so that's why it is not aromatic one. Okay, and in the second one, here is the negative charge, right? So means delocalization is possible over here, so that's why here are the 6 electrons are there, 6 pi electrons, and the 6 pi electrons means the your compound is cyclic in nature, right? So here it is all the atoms are sp2 hybridized, means it is a planar, that all are in the conjugated system, right? So means that compound is your aromatic compound, right? Cyclopentadiene anion is your aromatic compound. Okay, next example, cyclopentadienyl cation and the cyclobutadiene. So पहला वाला कंपाउंड हम अभी देखते हैं cyclopentadienyl cation, राइट? इसमें अब इसमें क्या, ये कंपाउंड साइक्लिक है, ये कंजुगेटेड भी है, बिकॉज पॉजिटिव चार्ज इज देयर, राइट? सो ऑल द एटम्स आर sp2 हाइब्रिडाइज्ड, मीन्स प्लेनर इन नेचर भी है, राइट? बट पाई इलेक्ट्रॉन्स कितने हैं? 2 + 2 4, बिकॉज पॉजिटिव चार्ज इज देयर, सो इट कैन नॉट बी like included in your pi electrons. Means what is meant by that positive charge? These are the vacant p orbitals, right? So how many pi electrons? These are the 4 pi electrons only. And in second compound, that is cyclobutadiene, right? So that is also cyclic, that is also conjugated, right? This one is also cyclic, that is also conjugated. The all molecules are all the atoms are the sp2 hybridized, means compound is planar in nature. And how many pi electrons are there? There are 4 pi electrons. So both the compounds are very similar, right? So the pi electrons are 4, means our compound is anti-aromatic, right? I hope you are clearing your all the confusions, all the doubts. So that's why we are looking all the examples related to the aromatic compounds. Okay, so next one, so these are the tropylium cation and tropylium anion. Okay, so first one, tropylium cation. Here tropylium cation is there. Okay, so in tropylium cation, so it is also cyclic in nature. conjugated system is there because one positive charge is there. Okay, sp2 hybridized atoms are there and pi electrons are the 6. 2 2 and 2 6 atoms are, sorry, pi electrons are there. Similarly, in tropylium anion there are also cyclic, conjugated, sp2 and planar, but pi electrons are 8 because here is a lone pair of electron and these are involved in your pi system, so that's why it is included in your pi electron. And that's why in tropylium anion there are the 8 pi electrons, in tropylium cation there are the 6 pi electrons. So that's why your tropylium cation, right, your tropylium cation, so that number of pi electron are 6 and number of pi electrons are 6 means your compound is, right, aromatic one, and the number of pi electrons are 8 means your compound is anti aromatic. I hope that all the doubts has been cleared from your aromatic and anti aromatic. और अगर मैं और एक ट्रोपिलियम का स्ट्रक्चर यहाँ पे निकलता और उसमें कोई पॉजिटिव या नेगेटिव चार्ज नहीं होता तो वो क्या हो जाता, नॉन एरोमेटिक, बिकॉज it is only satisfying that condition of like 4n plus 2, right, 6 pi electrons are there in that structure but one carbon is sp3 hybridized, so that's why that the third structure, that is the not aromatic. Okay, and these are the examples of fused rings. Okay, so in the first structure here, in the first structure, so this is also cyclic, conjugated, sp2 hybridized means planar in nature and the pi electrons are 10 because 5 double bonds are there and all are in a conjugated system and all are involved in a your pi system. So how many pi electrons are there? There are 10 pi electrons, so that's why this compound is, right, 10 means that compound is aromatic in nature. In second compound and third compound, right, so third compound, so what is the third compound? That is your indole, third one, right, so that is also cyclic in nature, conjugated, sp2 hybridized, pi electrons are 10 because on that nitrogen the lone pair are there. Okay, so lone pair are present on the nitrogen and that lone pair are involved in your pi system, so that's why 4 bonds means 8 pi electron and one lone pair, so that plus 2 pi electrons means 8 plus 2 10 pi electrons, and we know the 10 pi electrons means our compound is aromatic, right, our compound is aromatic. And the middle one, that compound is also cyclic, conjugated one, sp2 hybridized and planar in nature, but how many pi electrons? There are 8 pi electrons, and that's why our compound is what, anti aromatic. Okay, so please clear your doubts between aromatic, anti aromatic and non aromatic compounds. Okay, one more important thing from the fused rings, so always you have to choose the longest cycle, right, because the first condition is your molecule must be cyclic for your aromaticity, right, so you have to choose the longest cycle and only one cycle should be there in your compound. Okay, so finally the stability is there, like aromatic are the highly stable molecules, then non aromatics and then anti aromatic, these are the least stable molecules, right. So this is all about the aromaticity of your organic compounds, and that topic is very very important from your exam point of view, right. So thank you so much guys.